Hello again and welcome to the next lesson, Understanding Blockchain Technology from the course Theory of Blockchain. Today we are going to talk in more details about NEO. NEO is a non-commercial blockchain community-based project using blockchain technology and digital identification to digitize assets, automate digital asset management using smart contracts, and implement a smart economy in a distributed network. The founders of NEO are Da Hongfei and Eric Jan, who previously founded the Shanghai on-chain blockchain development and production company. Da Hongfei is more focused on promoting NEO and developing the blockchain industry, while Eric Jan is more focused on development and he is the main developer. Let's talk more about important dates in NEO's history. June 2014, AntShares founded. NEO is the development of AntShare. October 2015, the first crowd sale lasted 10 days, where 17.5 million NEOs were sold for $550,000. November 2015, testnet launched. October 2016, mainnet launched. June 2017, rebranding of AntShares to NEO. October 2017, the standard of token NEP5 is released. In the same month, Red Pulse released the first NEP5 token. July 2018, the decentralization of the NEO network has begun. July 2018, NEO 3.0 development started. Unlike many blockchains, NEO has a completely understandable concept. The main goal is to be a decentralized network for a smart economy. A smart economy consists of digital assets, digital identification, smart contracts. Digital asset. On Wikipedia, the following definition of digital asset is given. This is any entity in binary format that has the right to use property. Use right is a critical property for a digital asset. To make it clearer, I will give examples of digital assets. Digital documents, sound, music, or movies. As we considered in the previous lesson, placing digital resources in decentralized network is rather risky. And with the advent of the blockchain, owning and managing digital assets becomes much more transparent and safer. There are two forms of digital assets. Global assets, recognized by the entire system and can be used by any smart contract and user. Contract assets, they work only with certain contracts and cannot be used in others. For example, NEO or gas are global assets that can be applied in any contract on the network. But if you decide to create your own token for a project, it will work only within your smart contract. Digital identification. According to Wikipedia, digital identification is information about an object used by computer system to represent a person, an organization, an application, or a device. Blockchain offers a new way to identify individuals and the relationship between them. In order for digital identifiers on the blockchain to have legal value, they must be authenticated. The most widely adopted digital identification system is based on the X.509 PKI, public key infrastructure. NEO implements a hybrid mechanism that supports X.509 plus Web of Trust. Verification of identity on the project includes the use of a snapshot of the face, fingerprints, voice, SMS, and other multi-factor authentication methods. Smart contracts, as we mentioned in the previous lesson, are automated contracts in which specific instructions are written in the form of program code that are executed upon the occurrence of certain conditions. In order for a smart contract to be executed in a blockchain, it must have several properties. Deterministic, ability to complete deadline, isolation. Deterministic. A program is deterministic if it produces the same result with the same input data. There are various options when a program can act in a non-deterministic way. For example, call non-deterministic functions, use of non-deterministic data. Dynamic calls, since the called function or program is determined only at runtime. The call itself is non-deterministic. The ability will end at the deadline. In mathematical logic, there is the so-called problem of stopping. In mathematical logic, there is a so-called problem of stopping. Its essence is that there is no way to know whether a given program can be completed in a certain time or not. For smart contracts, This is a big problem because, by definition, contracts must be capable of being completed at a given time. There are several ways to enforce a contract, allowing you to go out of endless cycles that burn resources. Turning incompleteness, functionality limitation. If jumps and/or cycles are prohibited in the contract, therefore, the contract will not be able to enter an infinite cycle. Step meter and cost meter. A contract can track the number of commands executed and complete after a certain number has been completed. Another method is a commission for execution. When placing a contract, a prepayment is charged and each execution of a team requires a certain commission. If the commission for execution exceeds the received commission for placement, the contract stops. Timer. A timer is set in advance. If the fulfillment of the contract exceeds the deadline, it stops. Isolation. In the blockchain, anyone can place a smart contract, but no one can guarantee the absence of malicious code, viruses, or errors posted consciously and unconsciously. If the contract is not isolated, it can interfere with the performance of the entire blockchain. So it's very important that the contract be isolated to protect against negative consequences. Virtual machine or Docker. To achieve these conditions, smart contracts are usually executed on virtual machines, in particular Neo, or use Docker, for example, Fabric. The table below shows that virtual machines provide better deterministic completeness and isolation for smart contract execution. Let's compare Neo with some cryptocurrencies: Bitcoin, Ethereum, EOS, and Tron. Let's start with Bitcoin. In Bitcoin, as well as in Neo, the volume of tokens is limited. The difference is that in Bitcoin, mining is necessary for mining tokens, while in Neo, all tokens are generated initially. Bitcoin uses stateless contracts. Its blockchain processes every transaction as an absolutely independent event. Stake language for writing Bitcoin script implies executing a limited number of instructions with issuing true or false output. Where there is no ambiguity in principle, the language is not Turing complete. And this is a battle of two philosophies. Bitcoin apologists believe that smart contracts cannot be Turing complete by definition, and the very desire for Turing completeness of smart contracts is a false goal. On computing calculations only creates scalability problems. Others more argue that it's necessary to separate simple and complex calculations. The former are used in elementary smart contracts and do not require significant power. However, to perform complex calculations in the blockchain, it doesn't make sense. In addition, Bitcoin significantly loses by the number of transactions processed. It was this fundamental dispute that led to the emergence of Ethereum, the founder of smart contracts, and they have a lot in common with Neo. Both blockchains provide a platform for developing dApps and conducting ICO. Smart contract execution uses a cost meter. In Ethereum, Ether is required. In Neo, gas. Both blockchains are Turing complete. VM can calculate anything with enough memory. However, there are significant differences. In virtual machines such as Ethereum, you need to learn a new language, Solidity, to create smart contracts. The Neo developers sought to create a virtual machine that could give all the benefits of a virtual machine, as well as the flexibility of the Docker code. Ethereum proof-of-work consensus algorithm, similar to Bitcoin with block mining, which reduces network bandwidth. EOS positioned as the next step for Ethereum. EOS developers present it as Blockchain OS. The main account in EOS can manage the subsidiaries, giving them various access rights to write to send certain transactions at the same time. All accounts are inherited from block producer accounts, miners. As in Ethereum, there is mining at EOS, while in EOS there are only 21 miners. That is a producer block. Everyone is elected by a general vote, and the vote can be multi-stage. You vote for a candidate who can vote for some node that is candidate for a block producer. Instead of gas, a smart contract consumes a combination of three parameters: processor computing power, the amount of stored data, and the memory used. In fact, you are working with a virtual supercomputer, WebAssembly, which is considered more modern than EVM. is used as a virtual machine but will have to be programmed in C++. This combination allows you to achieve significant performance at a relatively low cost per transaction, but decentralization is the price to pay for it. Tron is a mix of Ethereum and EOS, essentially works like Ethereum, but the proof-of-stake consensus is taken from EOS. On the one hand, this solves the problem of the low speed of Ethereum. On the other hand, decentralization has been sacrificed. Technologically, which appeared much later than Tron, it does not carry anything new, but aggressive marketing allowed it to bypass the neo capitalization, which will only be a guess in the long run. In NEO, as mentioned earlier, two tokens. NEO, formerly known as Ant Shares, ANS, GAS, formerly known as Ant Coins, ANC. Owning a NEO gives the owner rights to manage and make decisions for the network. NEO token Integer, the 100 million NEO tokens are divided into two parts. First 50 million tokens distributed during ICO. The second 50 million were blocked until October 16, 2017, and will be gradually thawed and used to support NEO projects, as well as the long-term development, operation, and maintenance of the NEO ecosystem. 10 million to motivate NEO developers and members of the NEO Council. 10 million for the use and motivation of developers in the NEO ecosystem. 15 million for cross-investment in the other blockchains that belong to the NEO Council and are used only for NEO projects. 15 million for unforeseen expenses. The annual use of NEO should not exceed 15 million tokens. Compared to a regular exchange, NEO is a stock of a company. NEO coins are project shares that give rights to manage the network, such as voting, changing network parameters, and so on. Each share gives the holder dividends, GAS tokens. GAS is a token for implementing network management of NEO resources, such as contract and tokens. Users pay the cryptocurrency for the creation and launch of smart contracts. The fee is proportional to the computing resources consumed by the contract. These fees are distributed among the participants of the blockchain as a reward for their activities in the network. GAS is their fuel and is taken as a commission for operation with the blockchain. Dividends GAS accumulated as fees online. If the NEO is transferred to a new address, the subsequent generated GAS will be credited to the new address. As in the case of NEO, the total limit is 100 million tokens. However, unlike NEO, it's split up to 8 characters. 100 million NEOs are generated in the first Genesis block, while 100 million GAS will still be produced. They will be generated and distributed to the holders of NEO tokens in 22 years. The initial generation of GAS will be 8 GAS per 1 NEO, and will be decreased by 1 GAS per year or by 1 GAS by 2 million blocks until it reaches 1 GAS per 1 NEO. On a 45 million block, the total amount of GAS produced will reach 100 million, after which GAS will no longer be generated. GAS will be generated in the following proportion: 16% GAS first year, 52% GAS in the first 4 years, 80% GAS in the first 12 years. GAS will be released proportionally in accordance and distributed to the addresses. Holders of the NEO owners can get these GAS at any time. For the convenience of users, you can use the tool neo2gas.com to calculate GAS in accordance with the amount of NEO. One of the biggest problems that most distributed systems encounter is reaching consensus. This problem is usually called the problem of the Byzantine general. So what is the problem of the Byzantine general? So imagine that there is a group of Byzantine generals and they want to attack the city. They face two completely different problems. Generals and their armies are very far apart, so centralized control is impossible, which complicates coordination for attack. There is a huge army in the city, and the only way to win is to attack everyone at the same time. For the successful coordination of the army to the left of the castle, send a messenger to the army to the right of the castle with the message "attack in the environment." Suppose that the armies on the right are not ready to attack and say "no, attack Friday," and send the messenger through the city back to the army on the left. Here we are faced with a problem. Many things can happen to the poor messenger. He could have been captured, compromised, killed, and replaced by another messenger. This will lead to the fact that the army will receive inaccurate information, which can lead to an inconsistent attack and defeat. This is directly related to the blockchain. Blockchain is a huge network in which no one can be trusted. If you send someone 4 tokens from your wallet, how did you know that someone on the network is not going to interfere and change 4 to 10, for example, or to 40? Satoshi Nakamoto, the creator of Bitcoin, was able to circumvent the problem of the Byzantine general by inventing a proof of work protocol. Here is how it works. Suppose the army on the left wants to send a message called Attack Monday to the army on the right. First, they add an arbitrary hexadecimal number to the message test, and the resulting text is hashed. Suppose that the armies decide to exchange only messages, which when hashed produce a result that starts with 5 zeros. If the hashing conditions are met, they will send a messenger with a message hash. If not, they will continue to pick a hexadecimal number until they get the desired result. This is a rather lengthy process requiring a lot of computational resources. If the messenger is intercepted and the message is forgot, in accordance with the properties of the hash function, the hash will change. If the generals on the right side see that the hashed message does not start with a required number of 0, then they can simply cancel the attack. This is the health check protocol used by Bitcoins and Ethereum. The problem is that proof of work is extremely expensive and inefficient in terms of energy. Of course, there are other mechanisms for consensus. Ethereum plans to move to the proof of stake. Nevertheless, Neo decided to use an interesting system of consensus mechanisms. This called Delegated Byzantine Resiliency, or DBFT. Let's see how it works. Imagine that there is a country. In this country, there are many citizens. Each of these citizens will choose a delegate who will represent their interests and make them happy. The job of these delegates is to enact laws that will make citizens happy. If they do not do their job, well, then the citizen can simply vote for another delegate the next time. So how do delegates make laws? One of the delegates is randomly selected as a speaker. The speaker looks at all the requirements of citizens and creates the law. It calculates the happiness ratio of these laws to see if their numbers are enough to satisfy citizens or not, and transfers them to delegates. Then the delegates independently verify the speaker's calculations. If the coefficient of the speaker and the delegate is the same, then he gives his consent. If not, express mistrust. 66% of delegates must give their consent to the adoption of the law. If the majority is not reached, a new leader is chosen and the process begins again. So let's see how this applies in the blockchain. Citizens are those who own Neo tokens or ordinary nodes. Delegates keepers, blockchain. To become a blockchain keeper, you must meet a certain skill level, have a special equipment, dedicated internet connection, a certain amount of gas, 1000 in accordance with the basic crypto article. Citizens' requirements are basically different transactions made by token owners. Law is the current block that needs to be added to the blockchain. The happiness factor is the hash of the current block. Now there are 2 cases in which one of the participants may act maliciously. Case 1. Speaker traitor. In this case, the presenter sent a malicious message B to 2 delegates and an exact message A to 1. This script is easy network distribution will not work because of the rule of the majority. 2 delegates will see that their hash does not match the reporter's hash. And 1 delegate will see that their hash matches perfectly. However, 2 and 3 will reject the proposal and consensus will not be reached. The presenter will be deleted. Case 2. Delegate traitor. The speaker sends the correct message to all delegates, but one of the delegates decides to act maliciously and states that their hash does not match the speaker's hash. However, as can be seen, since 2 out of 3 delegates are not malicious, they will approve a law that will be passed after reaching a consensus of 66%. As you can see, DBFT is a very interesting form of consensus mechanism. Delegate traitor. The speaker sends the correct message to all delegates, but one of the delegates decides to act maliciously and states that their hash does not match the speaker's hash. However, as can be seen, since 2 out of 3 delegates are not malicious, they will approve a law that will be passed after reaching consensus of 66%. As you can see, DBFT is a very interesting form of consensus mechanism. As we mentioned earlier, the goal of NEO was to take full advantage of the virtual machine, as well as the flexibility of programming languages. Let's see how they managed to do it. NEO Smart Contract System consists of 3 parts: NEO Virtual Machine, Interop Service, DevPack. Interop Service increases the utility of smart contracts. This allows contracts to access data outside of NEO VM without compromising the overall stability and efficiency of the system. Currently, the interoperable service level provides some APIs for accessing the data chains of smart contract chain. Data it can access: block information, transaction information, contract information, and asset information. It also provides storage space for smart contracts. DevPack includes a high-level language compiler and IDA plugin. Because the NEO VM architecture is very similar to the JVM and the .NET runtime, it allows you to program contracts in other languages. As you understand, this significantly reduces the time spent by developers to learn how to create smart contracts. NeoID is a specific standard for identification on the blockchain, which should serve as the basis for the platform. It will serve as an infrastructure for serving global standards for digital identification certification. Smaller scale transaction and smart contracts that do not have a pre-established NeoID can receive priority to confirm blocking by paying an extra gas to get to the top of the queue. NeoX is an interoperability agreement like a Lightning Network. Any chain should be compatible with NeoX. If they are compatible with Neo contract, NeoX allows you to exchange both transactions and digital assets. The interaction between chains can occur in form of atomic exchanges of tokens between users in chains, or the execution of parts of the smart contract on several blockchain platforms. The agreement on the exchange of assets between blockchains ensures that all stages of the entire transaction process will be either successful or unsuccessful. NeoFS is a distributed storage protocol that allows the blockchain solution to scale. It uses DHT, data hash table technology, which is also used in BitTorrent protocol for more optimized data storage. This system divides large files into small files or fixed length and stores them on different nodes, thereby balancing the network and its contents. In addition to files, you can select the parameters of the required level of storage reliability, which determines how many nodes should store this information, which allows the creator to choose the optimal level of gas storage commission. The higher the reliability, the more gas will have to be paid. NeoQS, Neo Quantum Safe, solves the problem of asymmetric encryption used, for example, in RSA as well as in ECC, so favorite elliptical cryptography, used in most cryptocurrency. The cryptography based on quantum lattices used in NEO allows you to bypass a possible quantum crisis. Future features of the NEO blockchain. The development of NEO 3.0 began in the fourth quarter of 2018, and it's scheduled to be completed in the second quarter of 2020. The NEO 3.0 roadmap announced at the last DevCon in Seattle includes some architectural improvements. In DBFT 2.0, a recovery mechanism has been added that will significantly improve the stability of the consensus algorithm. Now, in the event of the network failure or node failure, recovery will be faster. In NEO 3.0, it's planned to significantly reduce the cost of deploying and executing contracts. Prior to the implementation of NEO 3.0, projects can apply for grants from the NEO Foundation to recover the cost of contract deployment. In NEO 3.0, the possibilities for contract interaction with the internet will be expanded. Embedded Oracle will appear. It will allow contracts to gain access to internet resources during execution. Disagreements between the nodes when working with internet resources will be resolved. Using DBFT 2.0, developers will have the opportunity to implement more complex oracles, to develop more diverse applications using external data. In Neo 3.0, the implementation of the P2P protocol will change. UDP support will be added and compression will be added, which will significantly improve TPS and network stability. In Neo 3.0, Neo VM will be completely separated from the blockchain and will become a pure virtual machine. It will be easier to implement native contracts. Neo VM application scenarios will appear outside the blockchain. Neo VM can be integrated into any IDE and smart contracts debugging will be available without blockchain data download. In addition, Neo VM will also include some new features such as support for static elements, exception handling, and others. Since global assets are not integrated with smart contracts, it's very difficult to manage global assets in smart contracts. Almost no one uses their assets in their applications, and most developers use contract assets. For this reason, global asset support in Neo 3.0 will be discontinued. In Neo 3.0, all assets will be created in smart contracts, including Neo and Gas. Having got rid of global assets, it will be possible to unify all types of transactions. Currently, there are 9 different types of transactions in Neo 2, and after switching to Neo 3.0, there will be only one type of transaction that is used to execute smart contracts. Also, a simplified transaction verification model has been proposed, which will significantly increase the speed of their transaction verification and will allow performing these checks. Due to these architectural changes, the performance of Neo 3.0 will be increased by several orders of magnitude. Not all planned improvements are compatible with Neo 2, so Neo 3.0 will be launched as a new blockchain network with the genesis of the block. Before the launch of Neo 3.0 mainnet, there will be 2 parallel branches of development. Neo 2 and Neo 3.0, since most of the Neo features in Neo 3.0 are backward compatible, the development efforts of Neo 2 will disappear and will be transferred to Neo 3.0. After the launch of Neo 3.0, mainnet will provide financial and technical support to help developers migrate. In the second quarter of 2019, Neo 3.0 testnet will be available for developers. All developed features will first be deployed to testnet to allow developers to test their applications. After completing the development of Neo 3.0, the testnet will be closed and replaced with a new testnet, which will be identical to the core Neo 3.0. In the first quarter of 2020, migration is planned to begin. The migration of dApps and users from Neo 2 to Neo 3.0 is inevitable. Currently, Neo 3.0 functions are still under development. Modifications are possible. So at this stage, it was illogical to develop a comprehensive migration plan. However, the basic principles are set as follows. Data and transaction records in Neo 2 will be stored permanently. Migration will be modeled in testnet to ensure a smooth transaction. Costs incurred during the migration process, such as contract redistribution and testing, will be reimbursed by the Neo Foundation. The NGD team will provide comprehensive technical support for dApps migration. Holders of tokens will have to change tokens in order to activate Neo once in Neo 3.0. Holders of tokens will have to change tokens in order to activate new ones in Neo 3.0. Exchange users will not be affected. In order to encourage users and dApps to migrate, a plan to encourage early users will be developed and implemented. That was the second lesson in our course, Blockchain Theory. Thank you for watching and see you in the next lesson.